Happy New Year, everybody. Chris Graham from More Beer joins me this week to discuss rims, herms, and other large-scale all-grain brewing systems. This is BeerSmith Podcast number 140. This is BeerSmith Podcast number 140, and Happy New Year. It's early January 2017. Chris Graham from More Beer joins me this week to talk about rims, herms, and large all-grain brewing systems. Thank you to this week's sponsors, Craft Beer and Brewing Magazine. They're running an amazing deal right now, only $19.99 for a year-long subscription or $17.99 for the digital edition. Every issue of Craft Beer and Brewing Magazine is packed with articles for homebrewers and beer lovers. And you can read my new column, which is called Ask the Experts, there as well. Take advantage of their special deal now at beerandbrewing.com. Again, that's beerandbrewing.com. And also the new Brew Vision thermometer from Blickman Engineering. This interactive wireless digital thermometer connects right to your iPhone or iPad and lets you remotely monitor and record temperatures. You can download your recipes right from the BeerSmith cloud and set updates or alerts as you brew. Get the Brew Vision Bluetooth thermometer today, another innovation from BlickmanEngineering.com. Again, that's BlickmanEngineering.com. And finally, BeerSmith Mobile, the mobile version of BeerSmith, is a perfect complement to our desktop brewing software, and I just published a new version. It includes all the tools you need to create recipes on the go, share them with friends, and act as a pocket brew timer. Check out BeerSmith Mobile at beersmith.com/mobile, or you can find it on the Google Play, iTunes, or Amazon app stores. And now let's jump into this week's episode. This week, my guest is Chris Graham. Chris is the president of More Beer and More Flavor Inc., one of the top online suppliers of brewing ingredients and equipment. He also teaches at the world-renowned Cybele Brewing Institute, and we've had Chris on the show, I think, 5 times now, Chris. That's pretty amazing. Welcome back.
Thank you. Good to be here.
Chris, it's actually been quite a while. I think it's been almost a year and a half since I had you on last. It was, episode number 107, a year and a half ago. What have you been up to the last year and a half? The twins doing good?
The twins are doing well. They just turned 4 last week, so that's been a big part of what I've been up to. And then the other part is my other child, the company, we moved. So while it was only 12 miles, it might as well have been 1,200 miles. So we're in a much larger location, and it's all geared towards getting our orders, being able to carry more inventory and getting our orders out faster.
And I think we talked last time, you have another office in Pittsburgh, PA now, right? Because you're located in the Bay Area, right?
We're in the Bay Area in a town called Pittsburgh, which happens to have a steel mill.
Which must be very confusing.
It's never confusing when talking to a vendor about just sending it to our Pittsburgh location.
And then your other location, of course, is in Pittsburgh, PA, right?
Yes. Luckily, it's technically in a town called Ambridge, which is in Pittsburgh area. So that helps quite a bit. Then the other big project we've worked on here that we released about a month and a half ago is a website dedicated to the pro brewers. So it's the morebeerpro.com, which we've had up for years, but we've never actually made it truly dedicated to the small brewery, and special pricing for them, and you have to create an account and show you have a brewer's permit and everything like that. But it's been a lot of fun to finally have that.
That's awesome. Are you doing a lot of business with pro brewers now?
We are. We've watched a lot of our friends go pro over the last 20 years. So it's been great to see them, but we've never really had anything dedicated to their size. And then we acquired a wholesaler 2 or 3 years ago called Brewmaster, who did sell to a lot of breweries. So over the last year, we've integrated our systems together, and using that infrastructure, really much better able to serve breweries from grain, glass bottles, and any other R&D equipment.
And I think Brewmaster makes the SS Brewtech line of equipment. Many people are familiar with their fermenters. I think they make boilers too, right?
Yeah, no, I wish we own them, but we do not. We are one of their distribution centers, though, or their U.S. distribution. Okay,
so Brewmaster's the distributor for that, right?
Exactly.
Yeah. Well, kind of in line with that, today we were going to talk about larger all-grain brewing systems, including things like three-tier rims, Herms, K-rims. There's direct mash heat, a whole bunch of them. First of all, let's talk about why the old pot and igloo cooler really starts to break down as you start going from 5 gallons or 19 liters towards 10 gallons or 38 liters or even more.
And there's nothing wrong with doing a larger batch with those coolers and such, but obviously you have to buy bigger equipment. It also gets really heavy. If you're going to have a traditional 3-tier system, it's heavy and dangerous, let's say, to have your hot liquor, your hot water at 170-ish degrees above your head. And I know this because I did it. It's one of those things where and lifting that kind of volume after the mash, lifting that kind of volume to get the hot water in place, it's just constraining. So with that, we typically want to use something different to do our mashes with.
Yeah, I mean, 10 gallons of water is like 84 pounds without the container, right? So
exactly.
So, I mean, you're lifting maybe 100 pounds of wort and kettle up, trying to dump it, starts to become a real problem, especially if that's hot, potentially boiling hot water, right?
Exactly. And in my 20s, I would have told you, it's fine. But in my 40s, I'm starting to say, hey, that doesn't seem so smart.
So instead, we start using static kettles and pumps to move wort around, right?
Exactly, and that's where once you incorporate a pump into the brew house, it makes life a ton easier. And what we'll cover today with using it for mash is just one component you get to use this pump for.
And here's a pump, what a typical pump might look like, right?
Exactly. The mag drive is definitely the typical homebrewer's pump. It's inexpensive, easy to use, and now there's kind of 2 major manufacturers, so they've definitely driven the price down.
Awesome. We'll talk about pumps in a minute, but let's talk about the basic 3-tier system, which is sort of the standard, 3-kettle system that we see. Can you walk us through that system and how it operates?
Yeah, so typically you have 3 vessels, and I'll get rid of the easy ones first. The boil kettle is the last in the flow, and it is typically used just for the boil. But then you'll have a mash tun, which we'll also call the lauter tun, and a
usually
hot
in the middle,
tank.
Right?
Exactly. It's typically the middle, whether that be side by side like this picture or a gravity system where they're stacked one above each other. And then the topmost system, or in the picture you were showing there, the right one is the hot liquor tank. And the hot liquor tank, for all intents and purposes, is just a hot water tank used for sparging, and we can also use it for other heat control in the processes. But the mash tun being the special thing that most beginner all-grain brewers don't know much about. And the real key with that is the fact that it has ability to separate solids and liquids, meaning a false bottom in there. And that false bottom can be made up of different ways. It can, and I know you have other episodes on there, and I think I've done other episodes with you on that. But the most common is some sort of perforated stainless steel to help separate the grains above the true bottom so that the liquid can flow through, separating the grains and liquid.
Right. And, a lot of these systems really differ in just how they move the wort around and also how they handle the mash tun, right?
Exactly. And that's kind of what the key differences amongst a lot of the systems are. But in that mash, the other thing I didn't describe is, so we're going to take our grains, very, very rudimentary description of this. We're going to take our grains, we're going to convert the starches to sugars using the right hydration level of water to grain and the right temperature to release an enzyme that does this conversion for us. And then we need to separate those sugars that are formed, and we're going to rinse those sugars out using the hot liquor tank water, and then collect them all into the boil kettle for the boil.
Right. Let's talk about the mash tun for a minute. So one option is obviously to go with an insulated mash tun. You can still use an igloo cooler, or there's even people that have, they'll put large insulation systems around their mash tun, right?
Exactly. And depending on how cold your ambient air where you brew is to how important this is. Mash itself is like an insulation layer, meaning it's thick. And so it won't just instantly change temperatures, but if you brew in Minnesota in your garage in the wintertime, having that extra insulation layer will definitely help you keep at the right temperatures a lot easier. Now, if you're just using one of those igloo coolers and you're just going to go the entire hour with no other way to control your heat, the more insulation, the better. So typically you can get a got cooler, an igloo cooler, one of those brands, a domed false bottom and a little conversion kit for the spigot. Very inexpensive, very easy to do, and they're very effective. The pros are you get that temperature where you want it to be. Now, keep in mind, most of your conversion is going to happen fairly quick, first 5 to 10 minutes, but then the removal of sugars, you really want to set for at least 45 minutes, more like an hour, to be able to have that sugar be very rinsable out.
Right. And so you got an igloo cooler, that's always an option, or you can even insulate a stainless steel chiller. But as you mentioned, once you add a pump in the system, things change, right?
Exactly. The need for all the insulation goes away. So when we're adding this pump, we're adding this ability to do a recirculation. And with that, we can have that liquid flowing. So envision having your false bottom and you have a spigot, so the liquid's dropping underneath the false bottom and going out the spigot into a pump, and out of that pump into something that's going to heat that liquid back up again, and then back into the top of the grain bed flowing back through again. So with that, instead of needing to keep this one constant temperature by really doing tons and tons of insulation, now you can adjust what that heat source is to keep your mash at a consistent temperature.
And essentially that's what we call a recirculating mash system, right?
Exactly, and that's where we're going into. And one of the more common ones is called rims. And that is that ability to heat that liquid up in line.
So I'm going to bring up a picture. Here's a typical rim. So this is a Blickman hop rocket right here. I'm sorry, rims rocket, right?
Yep.
There we go. And that's pretty easy to understand. It's got an input, and it's got an output, and it's got a heating coil, right?
Exactly, and that's a very common. Some go in a smaller chamber, some go in a longer chamber, but the whole concept is we have an electrical element, an element powered by electricity that turns on and off based off of the temperature of the liquid flowing through it. And you can actually control it based off of where you want to say this is the temperature of my wort.
So with a rim system, you have pretty precise control over it, right?
Exactly. You have very precise control. Some rim systems, some people run the rim systems different. Some run the temperature of the outflow of the rim's coil itself. Some run it as the whole temperature of the mash. Either way, you have very tight control of what you're keeping your mash at.
Okay, and then the other popular system, or another popular option, is something called Herms, right?
Exactly, and Herms is something I'm very familiar with because I've been selling system with Herms for 15 some odd years now. And it's very similar in that you have something that the liquid's going to flow through, an ability to control its temperature and come out, but instead of having an electrical element inside the chamber, you're using a copper coil or stainless coil that's sitting in a hot water bath. And the reason we chose Herms that long ago was knowing we'd never have any potential scorching or browning in what some cooks might call a double boiler situation. In most cases, I'm keeping my Herms hot water bath about 15 degrees above what I want my mash at. So I'm never really able to bring the temperature of my wort flow very far above what my temperature of my mash is to be. So with a rim system, you have to have good controllers to keep you from having too high of a heat differential of what's passing through that coil. So let's say if you were accidentally getting all that liquid to about 200 degrees, that's an awfully high temp coming out of your rims coil, where with a Herms coil, you just don't have that ability to have that big delta T.
So with a rim system, you have the potential to overshoot it, maybe. But with a Herm system, you're typically, I think most of them. I don't have the diagram up here. I'll pull a diagram up in a second. But most Herm systems, they recirculate through the hot liquor ton, right?
Herms goes through the hot liquor. I've seen very few that go through another vessel. So you're controlling a hot water bath is really what you're controlling in a Herm system. And I will say to this,
so here's
most of the rim systems built today have great controllers to prevent that.
Right. So here, so explain this diagram. You sent me this diagram. Here's walk us through this.
So the top vessel in this particular system is the mash tun.
Right.
So the origin is the spigot at the the ball valve at the bottom of that mash tun. So the liquid's flowing out of there, and that's where the arrows are. They're going down to the pump. They're going, accelerated from the pump through a coil that's in the lower tank underneath the mash tun is the hot liquor tank, and there's a copper coil in there, and it's going in there, heating up in line, and then coming out of there and up into an adjustable height sparge arm in the mash tun.
So essentially, while you're heating up the water for the sparge, you're also heating up the mash tun and keeping the mash tun at a constant temperature, right?
Exactly, and I typically preheat my Herms hot liquor tank first, because that way it's kind of the engine that drives the heat exchange. So I don't want to, accidentally start it when it's at 67 degrees and I dough in for, let's say, a 148. That'd be silly, because then I can't control it. I get it up to at least about 15 degrees above what I want that set temperature is. Now, with that in mind, I got to brew at Sierra Nevada recently in their R&D system, which they have one of our systems. Mm-hmm. And they found they actually have better success with a constant recirculation and then adjusting the hot liquor temperature rather than turning on and off the flow based off of the mash tun temp. So, and that makes a lot of sense to me, but one of the things they're very, very good at that most homebrewers aren't as good at is keeping their mash pH precisely in the right area. And since they're brewing the same beer over and over and over again, they know they're at between 5.1 and 5.3 pH, and so thusly tannin extraction isn't an issue for them.
Right, and we've talked pretty extensively about mash pH and why it's important for home brewing several times on several different episodes, I think now.
Exactly. Yeah. In fact, I got some of my information off your website when I was just learning more about the exact impacts.
Yeah, I got a bunch of new tools in BeerSmith to do it too, which is nice. Been awesome. Using them. In fact, I brewed on Sunday and used them quite a bit. Well, I wanted to talk about some of the other variants. There's also a whole bunch of different variants. Let's talk about Kettle rims, for example, used in the Brew Easy system. I actually just picked one of these up myself. Let's talk about how that system works.
Yeah, so all of those systems out there, what's funny is I coined them as like a mechanical brew in a bag system. And the Brew Easy is slightly different from the other ones I had in mind, from the Braumeister, Grainfather, and a number of those systems, where it's literally one vessel. The Brew Easy is two vessels, but doing very similar things, having a heater element somewhere in there, flowing the liquid through. So you have a recirculation, so you're distributing that heat in the mash itself. And what's really nice about all those systems and Herms and rims is you're really keeping the entire mash tun at the right temperature, because you have recirculation going on, where before you had that kettle, you had 1 point of temperature reading, but you could actually have multiple points of temperature in the mash tun just from stridations of temperature and such. But in all these systems, they incorporate a pump that does this recirculation and thusly keeps them all evenly temperatured. Now pulling up that Brew Easy,
yep.
Yeah, your mash tun, And correct me if I'm wrong here, Brad, that's on the top, correct?
Right. Yeah, the mash tun's on the top, and then the heating element and the boiler are on the bottom.
Exactly. So you're flowing with the coils in the bottom vessel, heating that liquid up, and then pumping it back up onto the top of the mash tun where it's flowing through. If your customers have probably seen products called the Braumeister and Grainfather, same exact thing, but what they're doing is having the electric coil either in around the basket, so it's in the same vessel, but it's actually on the outside of the basket, or on the bottom of the whole entire kettle, so that as the liquid falls through and goes to where the pump is, it's being heated in that area, and then that heat is distributed by the pump.
Right, and that's a direct heat mash tun, which is also very common used in 3-tier systems. You see a lot of 3-tier systems that have a heating element right under the mash tun, right?
Exactly. And in our systems, we put a heater element put a burner right on the mash tun, but I typically save that mostly for heating my strike water. And then if the only time I'll use it in the mash is typically for doing a mash out.
Okay, so there's a whole bunch of ways to heat it, but if you got the pump, you can maintain the temperature pretty accurately. What kind of control systems do you use to actually maintain the temperature? Obviously, you have to have some kind of a control system that's monitoring the temperature and adjusting the heat source or adjusting the circulation.
Exactly. The most basic one is your eyes. You could easily just run any of these systems, rims, herms. Rims might be a little tougher, like we talked about how much electricity is going to that coil and the flow rate you're going through. That one might be a little tougher. So if you're going to do that, have a temperature thermometer on the out of the herms coil and do a lot of your readings based off of that. But either way, you're just running it till you get to a desired temperature in the mash tun and then turning it off. So there's no reason you need a controller, but a controller is a nice little helping hand that is easily added on. You could do it as easily as a Ranco controller or a Johnson digital controller that's going to turn on and off a pump.
Yeah, I think they have these things called PIDs, right? You can buy a PID and potentially wire up your own controller, right?
I was going to say the Ranco and Johnsons are the easiest ones. They're very basic ones. Then you could get into PID controllers, and it doesn't take a whole lot more knowledge to use them, and they're not that expensive. But you're probably going to have to do a little more wiring on your own and a little more learning of how to run them. But you could get very precise control. And then there's a whole bunch of people using Raspberry Pi, Arduino, stuff like that to really have some fun, which is kind of incorporating a PID controller, and you could do more automation to your brew house with them.
Yeah, and a lot of these are using microcontrollers, so you can take a microcontroller, which aren't expensive anymore, actual small computer basically, using Raspberry Pi, for example, and then wire it up and have it control your system.
I was going to say, our top-of-the-line system, we just do a simple microcontroller. We had to print a few boards to get it to work, but then we have a 7-inch touchscreen, and we control...
This one has a touchscreen, I think, there, right?
Yep, that's exactly it. And we're controlling your mash temperature and your hot liquor temperature. We have safety features. We control your pump during the sparge, control your pump during the mash, give you timers during your boil, stuff like that.
Awesome. And so there's a whole bunch of varieties. Let's see, I'm pulling up the Brew Easy here. It has the Tower of Power, which is a kind of it's a PID controller basically.
Yep.
Really nice. And you mentioned the touchscreen you have on yours, which is fantastic. So there's a whole bunch of options there, and of course you can always brew your own. The next thing you need obviously is a pump to recirculate the wort. So let's talk for a minute about pumps.
Cool. So there are many different types of pumps out there in the world. This has become, the one Brad has on the screen here is the most common for two reasons. One, it's inexpensive, and that's probably the biggest reasons there. And it's food grade all the way up to a boil. So with that in mind, it's kind of low price and safe to use. This pump has some benefits, features that some people consider benefits and features and others consider cons. One of them is it's not self-priming.
Yeah, and I ran into that. That's a challenge, isn't it?
It is, but it's also a benefit. So think of it in the mash tun. If you had a self-priming pump, one that could create suction, you would then have to build a grant to go on your lauter mash tun, because you can't make a suction under your false bottom, or you're probably going to impact your grain bed. So that's, while the downside is you got to get this pump started and flowing. The good side is, hey, I can't accidentally set my grain bed and accidentally cause a stuck mash. So pros and cons. This is also, you can control your flow rate in that kind of pump by putting a ball valve on the outflow, because it's just a magnetic coupling. If you accidentally shut it off, all you're doing is breaking a magnetic coupling and not actually destroying the pump.
Yeah, so let's talk about a couple of those concepts first. Priming, what's involved in priming? First of all, you got to put the pump at the lowest point, right?
Typically, that's the smart way to do it. I've seen people have it not quite be the lowest point, but you want it to be lower than your input feeding it. You also want to make sure you have lots of liquid feeding it. So you don't want to use a very small diameter line or fittings with small holes in them. You want to make sure the fittings you buy have, full port options on them, so that the liquid flow has the best chance of priming that pump.
So most of the time we're using like a half-inch inner diameter tubing is pretty typical, right?
Exactly. Half-inch fittings, half-inch inner diameter tubing.
And the silicone seems to be very popular because it's high temperature, right?
Exactly. And since these pumps can't make any pressure, they're also safe because they won't collapse on you. Silicone's not good to use on a gear-driven pump or others that can create pressure. And so, again, easy to keep food grade and safe. So you want to flow it in. And then on the output, you could do a number of different things. But one of the things I recommend is to put a T, a half-inch pipe thread T. They're very inexpensive. Mm-hmm. And then I put a ball valve on each out. And the reason I do that is you can actually make a bleeder valve to allow full purging of the head of the pump before you start the pump, so that liquid is in the chamber. And then once you do that and you know that it's flowing through because it's coming out the valve on the T side, close that off and then open the inline side of the T, the valve there, and then liquid can flow through, and you can use that valve to control the flow rate as well.
Right, because the biggest problem is if you just open all the valves with a pump sitting there, the pump actually prevents prevents the wort from falling down into the thing, and so you need some way to purge some of the air out there in order to get the thing primed.
Yeah, and it depends on what you're going to. If you're going to something lower, liquid is self-seeking and it'll get itself there. But if you're pumping way up, like in our picture where we're going all the way to the top of the mash tun, then we definitely want to make sure we bleed and fill that pump head before we turn it on. And then the hotter the liquid, the easier it is to remove gas from it. So the more priming can become harder to do and harder to keep. So you want to make sure all your fittings are good and solid, and that you have hose clamps on all of them, and that they're not leaking air.
Right. And there's a couple different makers of pumps, right? I think the March pump is kind of the standard, right?
March and Chugger have become the standards. March was the original, and then Chugger, I don't want to insult them, but they knocked off the March pump. They know they did.
I was going to say, a lot of the fittings are interchangeable, aren't they?
The head is interchangeable, I believe. But they did it at a lower price point, so good on them. And we've had, customers been using them for a year or two with good success. So I recommend the March if you want one that is going to last 10, 15 years. And the only reason I can say that is I've used them for about 20 with very little issues. And
there's two kinds of heads. I think this one's a plastic head here I'm showing here. Right.
This is a polysulfone plastic head. It's it's food grade at high temperatures, but many people nowadays want stainless, so they offer that at a slightly higher price point.
Right, and the only disadvantage of the plastic really is you just have to be a little careful with the threads here, right?
Yeah, you know where it gets difficult is you thread on all these T's and ball valves, so you make these leverage points, and yes, so they're a little more prone to breakage because of the leverage points.
Right. So that's the basics on pumps. Now, once you have a pump for mash recirculation, you can use it for a whole bunch of other things, right?
Exactly. In one of our systems, we use it for the mash, of course, but we also use it for sparging. I use it sometimes. I want to heat my strike water for my dough in my boil kettle because it's faster to heat in there, and then pump it over. So I transfer with it. I do chilling with it, and I clean with it. So, once you have this pump, you can then start doing other things. It so happened a friend of mine has a house kind of in the country, and they have a constantly recirculating hot water system. And turns out it uses the exact same pump. So he loves it because now he has a backup in case that system goes out as well.
And a lot of the larger systems have two pumps. Why do you have two pumps instead of one?
Mostly it has to do with the design of the brew house. So you have two systems of mine that you have photos of. One that's what we call the tippy dump, which is a mash tun on top of the boil kettle. And that system, we can just go with gravity since the mash tun is higher than the boil kettle. So we can get away with one pump.
There it is. I finally got it up.
There you go. So in that system, the boil kettle's off to the left, the mash tun is up top, and the hot liquor tank's down below. Well, we only need one pump to run that system. But then we have another system where we have three vessels side by side. And in that case, during the spars, there you go, we have two pumps. And for that reasoning, we have one to take you during the sparge from the hot liquor to the mash, and then one to take you from the mash to the boil.
So just a little more convenient having the two pumps, right?
Exactly. In fact, I'm a big believer in the gravity system, like the tippy dump or any system where the mash is above the boil kettle, because I like one pump. It's easier to run. It's easier to balance. Gravity is pretty consistent. You don't have to worry about gravity going a little fast or slow. But and then you're putting up the actual full gravity system. I love that. That system's great because gravity never fails. Power can go out, you could still brew, all of that, but you can't really do much control of it. Your dough and temperature really sets everything for the mash. You can't really adjust it much. You can put a flame on the bottom, but it's not ideal from that perspective. It's ideal from a simple, easy to use, compact system, but from a truly mash control, it's not the best.
Right. And finally, you often need to have a different chilling system. We talked, you actually did a whole episodes on chilling systems, but tell us why the old immersion coil may not be the ideal choice when you start going to 10, 15 gallons.
Yeah, and I'll say it this way. The old immersion chiller, we'll talk about it as a stagnant system, just one line in, one line out, and a wall of copper that's coiled up in there. And liquid, all by itself, convection doesn't happen very fast. Even if you heat or cool the hottest part, which is the top of the wort, still takes a while for that liquid to dense up, settle down, causing a convection. Now, with that in mind, having a pump, you can then put a third arm in there, which our friend Jamil did, and we now sell a system based off of that. You can actually introduce a whirlpool, a recirculation during this, and actually it does quite effective with an immersion chiller. You can also use other types of very effective heat exchanges, such as a counterflow chiller, where you literally have your wort flow is going in one direction inside a copper tube that's inside another copper tube with water going the opposite direction, and that's an extremely effective chilling. Or a plate and frame, which is essentially a bunch of stainless plates that are stamped with all these scattergrams of flow that the liquid will go through, giving a high surface area of stainless to the wort. And then on the other, in between the next two plates, is water flowing in there, and then vice versa. So you have a chamber of wort, a chamber of water, a chamber of wort, a chamber of water, and they're all going through simultaneously with just an extremely fast heat exchange. But having the pump allows you, one, to flow through more controlled, and two, it allows you to clean it out afterwards.
Right. And for example, here's the Terminator from Blickman, and it's actually a pretty compact little device. Yeah. Not very big, and like you said, you just pump, you just control the flow rate on the pump basically to control the temperature on the output.
It also allows you to go up to something. Let's say you have a conical that sits up on a stand. It allows you to not have to do gravity into that from the boil kettle.
Right. So, but these plate chillers or counterflow chillers tend to be much more effective as you start getting to these larger volumes, right?
Exactly. Your flow rate can be much faster through them, so your time of chilling is cut down. Most of these heat exchangers, if you have cold water, you're talking a gallon a minute. So you could chill 10 gallons in roughly 10 to 15 minutes, which is much, much faster than your standard immersion chiller.
Right. I was using the Therminator the other day, and it was nice because you could just dial it right into. I was trying to transfer it maybe 68 degrees, and it would just push it right through at 68 degrees. And like you said, it took maybe 10 minutes to move 10 gallons of wort. Fantastic.
Yeah.
So, walk us through a typical brew day for a 3-tier system. Let's talk about. I'll bring up the picture in just a minute of your 3-tier system.
So for me, I'm going to walk through herms, but you could substitute out rims. It doesn't really matter. So our typical brew day for me with herms is I start by calculating how much water I need for my mash tun, and I'll fill that up and start heating it with the burner underneath there. I'll fill my hot liquor tank up. Sometimes I do the hot liquor first, and I don't usually calculate. I just put in a whole lot of water and get it heating as fast as I can. When my mash water is at my proper strike temp, which for me is usually about 12 to 13 degrees above my dough-in, on a single infusion style mash. And my hot liquors, let's say 10 to 15 degrees above that temperature, I'll then dough in. Once I finish doughing in, I'll hook up with my recirculation arm in the mash tun. I'll set it to be right at the top of the grain bed, if not a little bit into the grain bed. And then I will start the pump. So it's pulling from the bottom of the mash tun through the pump, through the coil that's sitting in my hot liquor tank in this 170-ish degree water, up to the top of the mash tun where my sparge arm is, and it'll just run through. And I have a temp sensor that's about 1/3 up the height of the mash tun. That's reading my temperature of the mash tun, and then it'll turn the pump off when I get to the right temp. And then it'll hold me there until it drifts out of that temp range, i.e. lowering, and then it'll turn the pump back on to start the recirculation. And on a typical brew day, it'll run for, depending on how good my dough-in temp was, a few minutes to get me right to start with, then run after about 10, 15 minutes for a few minutes, then stop, and then do that again. And then on my automated system, I have it walk me through if I'm going to do more steps in my mash or my mash out, and it'll walk me up to my mash out, get me up to the 168 degrees or so, hold me there for the 15 minutes, buzzer goes off, and then I go and turn the pump, or it turns the pump off for me, but close the valve of the mash tun. And for me, all I do is remove the line from the mash tun to the pump, and I move it to the hot liquor tank. So I don't take all my lines off. I just move it to the hot liquor ball valve, and then I put a new line in that's just going to run me down into my mash tun into my boil kettle from the mash tun. So now I'm setting up to sparge, and so I keep my coil still in the hot liquor. So now the liquid's going to come out of my hot liquor tank through the pump, up through the coil, cleaning out all those sugars that are in that coil, up through the sparge arm, cleaning that out as well. And then in our system, we happen to have a float switch that's variable height, so we can adjust that and make it 2 inches above the grain bed or wherever we want it. And that'll turn on and off the pump, keeping me with my head pressure, because I do a fly sparge with our particular system. And then I open the ball valve up of the mash tun with my line going down into my boil kettle and set my flow rate that way. And there's a number of different ways. For my system, I use a shaker glass, pint glass, and it takes me about 20, my right flow rate is about 20 seconds to fill the shaker glass, and that gives me about a 45-minute sparge. About halfway into the sparge, I start turning on the boil kettle burner so that I'm not waiting till it's all the way full before I'm turning the burner on. But I don't turn the burner on right away because I don't want that high density, high sugary liquid that's the first runnings to be under direct flame load.
Makes sense, yeah.
And then now you're into your typical boil day of once it's up to a boil, you got to worry about the boil over and add your hops and your kettle additions and cool it. And then you're down to your cooling and using our pump to run through our heat exchanger and then to our fermenter.
So you pump all the wort out and then you're done. Talk about cleanup though too. Some of these systems, it's pretty nice having the pump to clean up as well.
Yeah, usually once you've the hardest part of most cleanups nowadays is just getting the physical grain out. But with all of these having false bottoms, and you could get all the liquid out of your mash tun first, which is key because that's your weight, that's your heat retention, everything like that. So usually during the boil, I drain the mash tun completely and let it sit for a little bit so that it can cool down a little bit. I scoop out the grains. I have one system that's on a tippy fulcrum that makes it really easy to tip out. But once you get the solids out, then in my hot liquor tank, I can get some water going, or any of the vessels, get some water going, add some PBW or whatever your cleaning choice is. And when you get it nice and warm, like 100, 110 degrees, really is effective. And since you have a pump, now you can recirculate it through all your coils, your tubing, your heat exchangers, especially the ones that are post-boil, because those are the ones that are most vulnerable to bacteria pickup. And really let the pump do the mechanical work. I'll set a timer for 15 minutes or so I remember to come back to it and do the next step. But it's really nice. It really saves you from running a lot of line brushes and taking a lot of things apart every time.
So the pump with a little bit of hot cleaning agent just cleans it all out for you.
Yep. And I do recommend taking your pump apart periodically to make sure it's clean and lubricated, which I think a lot of people forget with these styles of pumps. You don't have to do it every batch, but I would at least, let's say when you get it, brew 2 or 3 batches, take it apart and see how clean it's getting and decide how frequently you want to clean it out.
Yeah, I mean, the big problem isn't really that it has a lot of dirt in it, but a lot of times there's water sitting in the bottom of it when you're done brewing, and it, will slowly turn into mold if you leave it sitting long enough, right?
Exactly. And it depends on what people are cleaning with, to how many solids they're really getting out. Boiling water is good, but it still won't get all the solids out. So you want to feel, like I like to tell people, feel the veins on it that rotate around. And if they're super slimy, it's time to start cleaning them. And I don't mean they're greased from a silicone lube or anything. I mean if they're slimy, such as something is setting up on them.
Right. And it's pretty easy to take the head off those and just clean it out. 4
screws. It's very easy.
Yeah. Well, Chris, thanks for sharing that with us. I wanted to give you a minute here at the end to talk about some of the things you got going on at More Beer.
Oh, who knows what we got going on, Brad? No, we have a lot. We have a lot going on all the time. But
this is going to air in January, but your Christmas specials are up here on the front. So
yeah. Like every retail company, you have to have lots of Christmas specials. But we also have a lot of new products. One of we're carrying a faucet out of Australia called the Intertap, and it is amazing, especially for the price. It's actually an approved upon Perlick faucet, which was hard to believe that someone could do, and at a lower price point, and stainless.
And of course, Perlick has the forward seal, which has been very popular because it doesn't grime up quite as easily, right?
Exactly, and this is also a forward seal, but it's also it has more adjustments, floats it can do, so it has less leaking than the Perlick. It also has a screw-on tip that allows you to change it out. So if you want to change it into a stout faucet, they actually have a whole exploder kit that you just thread on. So you don't have to buy a special faucet now. You can use your same faucet. They're also working on counter pressure bottle filler attachment, a growler filler attachment, all these cool little things right off of this faucet.
So there, let's pull it up here. There it is right there. So it looks a little bit like a Perlick, right?
Oh, it looks exactly like a Perlick. And that's their lowest end one that they have to compete price-wise. So, but you can see that price point's pretty amazing. But they also make an all stainless version of that isn't ridiculously expensive.
Nice. And anything else you want to mention real quick?
This is coming out in January, but we have keg lines out there. Our torpedo kegs are hugely popular for us. Tons of kits, and just keep checking our website for more deals. And if you're not on our newsletter, please get on it because we're doing a lot more deals that way.
Awesome. Well, again, I want to mention the website too. Go ahead. I'm sorry.
The last thing I'll say is we're still independently owned. We're getting a lot of questions about that. I'm still one of the owners, and I'm still here every single day.
You haven't been bought out by InBev yet?
I have not, and we will not be by InBev.
Well, if they have enough money, maybe, no?
Well, I guess everything's for sale. You're right.
So I want to mention your website, of course, which is morebeer.com, right there, morebeer.com. And Chris, thank you again for coming on the show. Really appreciate you being here.
Thank you, Brad, for having me.
So again, my guest today was Mr. Chris Graham. Chris is the president of More Beer and More Flavor, Inc., also an instructor at the world-renowned Seibel Brewing Institute. Chris, a pleasure to have you on the show. Thanks.
Thank you.
Well, a big thank you to Chris Graham for joining me this week. Thanks also to Craft Beer and Brewing Magazine. Every issue is packed with great information for homebrewers and craft beer fans. Take advantage of their fantastic sale and get a 1-year subscription now for only $19.99 from beerandbrewing.com. And also Blickman Engineering, creators of the innovative new BrewVision wireless thermometer. Remotely monitor your brewing system from your iPhone, iPad, record data, set alerts, and grab recipes directly from BeerSmith. The BrewVision thermometer is another innovation from BlickmanEngineering.com. And finally, BeerSmith Mobile. The mobile version of BeerSmith is a perfect complement to our desktop brewing software. Check out the new version just released of BeerSmith Mobile at beersmith.com/mobile or on Google Play, iTunes, or the Amazon app stores. Thank you for listening. I hope you have a great brewing week.